So complete change of pace now. Moving on from radical functions, we're going to talk about rational functions. And if you think back to grade 11, you actually did one of these. We called them reciprocal functions, where you graphed 1 over f of x. And what you often had was a graph that looked something like this. There was a vertical asymptote, there was a horizontal asymptote, and you had this kind of a curve. Well, we're going to kind of expand that and look at a lot of different types of rational functions. One of the things you saw in grade 11 was that all horizontal asymptotes were y equals 0. That's no longer going to be the case. Okay, so today's lesson, what I actually want you to do is to use Desmos, and I want you to try to graph each of these equations or functions that I've given and see what you can notice about them. Okay, I'm going to do a few of them with you, but then I want you to do the rest and see if you can come up with some of the conclusions at the end of the lesson, and then we'll talk specifically about what does that mean when we want to graph a rational function. Okay, so taking a look at the first one, if you go on Desmos and put that into Desmos, I believe you're going to get a function that looks something like, it's going to be something like this. I think there's going to be a little bit of a break right here. Okay, and it's going to be a line. Alright, and then it asks, are there vertical asymptotes? Now, you're not going to see that on Desmos. Desmos doesn't put asymptotes in on the graph. What they do have is asymptotic behavior. Remember, asymptotic behavior means that the graph is approaching the asymptote. Okay, and so if you look at this graph, there are none. There are no vertical asymptotes. There are no horizontal asymptotes. But there is a non-permissible value of x. X cannot be negative 1. Now looking at that equation, why can't x be negative 1? Well, if we put a negative 1 in here, you get a denominator of 0. And you can't have a denominator of 0. Okay? So that's your first graph. I want you to do the rest of these. Okay? Then let's look at group 2. Okay? So if we do a quick sketch of this graph, alright, I believe there's going to be a horizontal asymptote at 3. Okay, so the horizontal asymptote will be y equals 3. I think there's going to be a vertical asymptote at x equals 1. Whoops. X equals 1. And I think the graph is going to look something like this. I'm not totally sure because I'm kind of just winging it, but it's going to look something like that. What are the non-permissible values of x? They're usually the vertical asymptotes. X can't be negative 1. Okay, so try a few more of those. Then we'll go to group 3. Quick look at this graph. This will have no vertical asymptotes. It will have a horizontal asymptote at y equals 0. Okay, and again, for now, you don't know why that's happening. I just want you to observe the graph and try to make some conclusions. Okay, and so I think this graph will look, let's see, if we have 0, you're going to have a value of 3. I'm pretty sure this is one of those speed bump graphs. Okay, but you can check that. What are the non-permissible values? There are none. Why is that? Because x squared plus 2 will never equal 0. There's nothing we can put in there. We can't get a negative 2 out of a square. Okay? So try the rest of these. I've actually posted all of the graphs. If you look in the notes under this unit is graphing radical and rational functions. There are pictures of each of these charts filled out. Okay, so I would like you to do that. Fill out the charts. All right. Just to be clear, where are you looking? Look under the links for radical and rational functions. Okay, it's our 5th unit. And the answer should be in there. Okay, and then I want you to take a look at these notes here. I would like you to try to come up with something in here. what have you noticed by doing these graphs? Okay, we'll start tomorrow's lesson by filling this out. All right, so that's all you need to do for today, is use Desmos to finish these charts. Okay, and once you've done that, we will continue with another lesson next day.